Right. So in our last video, we spoke about theorem one, right? And that, let's just recap that quickly. We said that there's a line from the center that's perpendicular to the chord, and because the line is perpendicular to the chord, we know that that line bisects the chord, so those two will be equal. AB will equal to BC, right? Um, that is theorem one, right? But we also need to know that the converse of theorem one is also true, or the reverse of theorem one. So when we look at the converse, it looks like this. These two are equal, right? So now you are given the fact that they are equal, you are not given the 90. Okay. Now this theorem, I am going to prove it for us, but when you do it, you don't need to prove it, right? So I told you there are going to be some that you need to be able to prove. This one you don't need to prove. But let's go over it quickly. So again, we'll do our construction. So we'll fill in these lines. Again, they are radii. So let's say that OA is equal to OC. Our reason for this is radii. Radii, okay. All right, that is radii. Then let's also say AB is equal to BC. The reason for that is given, right? So in this case, that information was given to us. All right, so we said this one and this one, and then we also said this one and this one, and then we already spoke about these triangles, right? So there's a triangle formed, ABO and CBO. So those two triangles are formed because these are the same length. We know it's an isosceles triangle, so therefore angle A will equal to angle C. Reason is angles opposite equal sides, right? Okay, angles opposite equal sides. Let's maybe just rewrite that so that we can all understand what I am writing. Angles opposite equal sides. Okay, that's a bit better, right? And now we have these three statements. This is a side, this is a side, this is an angle. So it's okay. Let's highlight it quickly. We are looking at that side. We're looking at this side and this angle. That angle is in between. This angle here is in between the two sides that we have. So we can use side, angle, side as our reason for congruency. Okay, so we will say, therefore, triangle A B, that's a ABO, is congruent, and congruent is three horizontal lines, to triangle CBO. Our reason for congruency is side, angle, side. Great. All right, so now because we know these two triangles are congruent, what we also know, B1, right, is going to be equal to B2, right? So I mentioned B1, B2, but that's not shown on my picture. So if I do this, I just need to show that maybe that one is number one, this one is number two. They need to be equal. Why are they going to be equal? They're equal because of my congruent triangles, triangle ABO, congruent to triangle CBO. Okay, so there I'm saying that they need to be the same thing. And then I'm also going to say that ABC is a straight line. So by nature of it being a straight line and them being equal to each other, they would have to equal to 90 each, right? So what I'm saying is this. I'm saying that if it's a straight line, then B1, right, B1, right, that's a B, will have to equal, right, let's just write this, B1 plus B2, right? Because the straight line, it has to equal to 180 degrees. Because they are both the same, so we could say that it is both B1, which equals to 180 degrees. Right, so B1 plus B1, okay, that's like term, so we can say 2B1 is equal to 180 degrees. Divide both sides with your 2. So then you can say B1, which is also equal to B2, right, is both 90 degrees. All right, so let's go back to our picture quickly. What we're saying is this. Okay, let's see, maybe I can erase some of this for us. We are saying that if you are given this image, right, this image which tells us we have a line from the center OB to the chord, and that line is in the midpoint of the chord. That line is in the middle of chord AC. So if you have a line from the center of the circle to the midpoint of the chord, right? So we are given that these are equal. Then what you know is that this is a 90 degrees. Okay, so I'm going to say the same thing again. I'm saying that if I have a line from the center of the circle to the midpoint of the chord, it forms a 90 degrees. Okay, so theorem 1 was the exact opposite. Theorem 1 said there is a 90 degrees, and because of the 90 degrees they are equal. The converse of theorem 1 says they are equal, and because they are equal, this is a 90 degrees, right? So the one tells me that there is 90, and because of the 90 they are equal. The other one tells me they are equal, and because they are equal there's a 90. So when we use the converse, we are going to say, let's just go look back at that quickly. We're going to say that OB is perpendicular, so we'll say OB is perpendicular to AC, right? And the reason for us saying this is line from center center to midpoint of your chord, right? Line from center to midpoint of the chord, right? Again, so theorem one tells us that, oh, we got rid of too much over there quickly. Right, theorem 1 tells me that because of the 90 degrees, I know this is equal. Right, the converse of theorem 1, because they are equal, that's 90.